All right, as we come towards the end of the course, we're going to get a little bit more into the physics, and today we're going to talk about motion and specifically the relationship between your speed, your distance, and the time elapsed. Just like force, pressure, and area, you can use a triangle to solve for speed, distance, or time. Once again, just reviewing between S and T, speed and time, we would multiply. And between distance and either of the bottom ones, that's a dividing line. So if you are solving for time, you cover up time and you do distance divided by speed, so on and so forth. So when I say speed, I could also say velocity. They're kind of measuring the same thing. Velocity is just a vector with direction. So if I jump back and forth between speed and velocity, that just because I'm used to using the vector quantity. So just bear that in mind. All right, and how do we find speed? Speed is equal to the distance you travel divided by the time it took you to do that. So the units for speed depends on what you're doing. So we know kilometers per hour. Americans know miles per hour, but you can also do meters per second, feet per second. It's always that per, right? The distance divided by the time. So be careful because sometimes you might have to convert. Specifically, you might be stuck doing a lot of time conversion. So let's quickly review that before we move on to the other calculations. So when you work and you want to produce, generally we're wanting to produce miles per hour or kilometers per hour. So we need decimal hours in order to proceed with that math. We don't want fractional parts. So when we look at this one, how many decimal hours is 5 hours and 39 minutes? Well, let's think of what it is as a fraction. We have 5 hours, so those are the wholes, and we have 39 out of a possible 60 minutes. So if I wanted to find the fractional part, I'm just going to take 39, the numerator, divided it by the denominator, and that will change it into, I think it's a denominator, we'll change it into a decimal. So 39 divided by 60 gives me 0.65. When I can smash those back together, 5 hours and 39 minutes is 5.65 hours. In the second example, we want to know how many decimal hours just a minute is. Well, if you want minutes to hours, that's straightforward. You're going to create that improper fraction. There's my minutes. If I divide it by 60, I'm going to change it into hours. And I get 2.97 hours, which is great if I'm doing math. But what if I was reporting back after and I said, oh, I traveled for 2.97 hours? That's not how we talk. So if we want to figure out hours in minutes, let's say, we're going to take the hours, set it aside, because we know we traveled for it full 2 hours, and we're going to take the decimal and turn it back into a fraction of 60 by multiplying by 60. That gives me 58, which is your minutes. So you're either always dividing or multiplying by 60 with time. So we know that it's 2.97 hours, it's also 2 hours and 58 minutes. What if I'm traveling a decimal of hours? How do I make it into minutes and then into seconds, minutes and seconds? So start the same way. If I want to take hours and make minutes, I need to multiply by 60. And that gives me about 14.16 minutes. Same thing, you don't say I traveled for 14.16 minutes unless you're like clocking a race or something like that. So we're going to take the 14 minutes, set it aside, then I'm going to take the decimal, change it into seconds, once again by multiplying by 60, and that gives me 9.6 seconds. I didn't ask for fractions of a section, so I'm going to round that up and say 14 minutes, 10 seconds. All right, that should be everything we need to know. This question is asking me to find the average speed from looking at my odometer reading and timing myself. So when you think about average speed, that doesn't mean you're always going that speed. It's not like a cruise control. You might go slower sometimes, you might go faster. I don't know what your speed looks like between the two time points, but I know by finding the distance you traveled and dividing it by the time, I can figure out your average. So let's start by finding out how far you went. 45781 was your final odometer reading. subtract where you started, 45652, and that gives you 129 kilometers traveled. Now they want the answer not in kilometers per minute, they want it in kilometers per hour, so we better take that 75 minutes, change it to hours by dividing by 60. You should never have more hours than you have minutes, and that gives me 1.25 hours. If I want to know my speed, it's distance over time, so 129 kilometers traveled in 1.25 hours gives me an average speed of 103.2 kilometers per hour. We're going to revisit some speedometer calibration from our gears section, but we're just going to figure out whether our speedometer is correct or not. So someone got a speeding ticket and is not happy, said they were going 100, and for some reason they got a speeding ticket. So you're going to take the car out. So your distance that you find, well, that you drive, is 8 kilometers. How long did it take you to do that? Well, we have 4 minutes and 30 seconds. That's not a useful unit, so I want to change that into hours. So I'm first going to take the 30 seconds, 30 divided by 60 seconds in a minute equals 0.5. So I've converted my time to 4.5 minutes. Now I want to convert it to hours. 4.5 minutes divided by 60 minutes in an hour. To convert the time to hours, 0.075 hours. Now I'm ready to find the speed that you are actually driving at. Distance divided by time, and I'm going to get 106.7 kilometers an hour. So even though you set the cruise control to 100, you are actually going 106.7, which is a little bit of speeding, not huge speeding. So let's say I'm driving in Alberta or somewhere where you're allowed to drive really fast, and I want to know how far I travel if my speed is a certain thing and my time is a certain thing. So we have to massage the formula a bit. Remember that distance is speed multiplied by time. All right, our time is a problem. It's in minutes. We're talking hours in the speed, so we want to change that. My time will be, and I'm inconsistent with my big and little t's as well, sorry. 45 minutes divided by 60 is going to give you 0.75 hours. So to find the distance traveled in the first scenario at 124 kilometers per hour, 124 multiplied by 0.75 tells you you can travel 93 kilometers in 45 minutes at 124 kilometers an hour. Now, the second example, we've dropped our speed, the time remains the same. So we just change our 124 to 100. It's like we cross the border into somewhere with 100 kilometer an hour limit. And we're going to get 75 kilometers if you drop your speed that much. I want you to be able to look at tables and graphs and kind of analyze what's going on in a trip and find speeds from those. So typically you'll get these, and if you have a table, it could have any kind of time interval here. They're nice and regular. It could be leaving a location, so you start at 0, and as you get further away, you go up. Here, these are like mile markers on the side of the highway, so someone is just making a note at each time of what mile marker they've passed to keep track of things. Lots of different ways. You can look at the odometer, lots of different ways. All right, so let's start by saying, what is the average speed for the entire trip? Well, the entire trip goes from 12 when you were at mile marker 120 till 4 when you were at mile marker 301. So we can see the distance traveled just by doing our finishing distance, our end distance, or mile marker, divided by, subtract 120. It tells you how far you traveled in between those two, and that's going to give you your 181. That's called miles, let's say. They said mile markers. How much time passed? 4 hours. We can see that, 4 p.m. or 4 a.m. and it's 12. So if we want to know the average speed, same, 181 divided by 4, and that's going to give us 45.5 0.25, I'm going to drop that just because I've run out of room, miles per hour. All right, we could also ask about speed within any interval. So the second question is asking what the average speed is between 1 p.m. and 3 p.m. So I go to 1 p.m. and I see that I was passing mile marker 168, and at 3 p.m. I was passing mile marker 257. So I figure out the distance traveled, 257 minus 168 gives me 89 miles. I did that in 2 hours. So my speed, same, is 89 divided by 2, 44.5 miles per hour. So that interval I was going slightly lower than the overall average. That's fine. That means at other times I was going faster. A jerk question that you could get is, when was a driver going the fastest? So that means you have to analyze your speed in every interval provided. Now, the nice thing about this is each of the time intervals change by half an hour, 0.5 hours as they go up. So really, you could just look at the distance you traveled between each time interval and compare those, but I'll try and do both. I don't have a lot of room here. So if I look at the first one, I kind of take 141 and subtract 120, and I find out that I went 21 miles. If I do 21 divided by 5, that's going to give me, I pick a color I haven't used yet, 42 miles per hour. So that's just that 21 here divided by the 0.5 it took me to cover the 21. I'll fill in the rest and then we can take a look. So I've just quickly taken my calculator and figured out all the distances between the mile markers. And if I wanted to the speed for each one, you're just going to double it. So we go 54 miles per hour, 52, that's fast. This is insane, 82 miles per hour. What happened here? 8 miles per hour, 36 miles per hour, 26 miles per hour, and some of my math might be off. Okay, so there's your speed for each one. And if I want to find which one's fastest, I'm just going to scroll down, look for the biggest number. I don't know what's going on here. Very lead footy. So when were you going the fastest? You were going the fastest between 1:30 and 2 p.m. How could you be going this slow after that? Well, maybe you were going so fast that you got pulled over by a cop and you spent, 20 minutes getting a ticket. Maybe you stopped for lunch. Maybe you stopped to go to the bathroom. There's lots of different things that can happen that kind of cause these fluctuations in average speeds over the trip. So I've taken the same table, except for the last value. I've changed that to mile marker 254, just so we can observe what happens on the graph with that. And I've plotted it on a distance versus time graph. So you always make time is always your x-axis because it is independent, and distance really depends on the time passing. So we make it the y-axis. So here it is, and each point's kind of dotted, and I tried to put the numbers on as well. And we can see where we were in that really fast interval from 1:30 to 2 p.m. is right here. And what do you notice about the line? The slope is much steeper, which means the velocity is faster. So the slope of the line on a distance time graph is the speed or the velocity. When we had that really slow part where we had 8 miles per hour as our average speed, we get essentially almost a flat line. If you stop and don't do anything, like don't move your car, so say you were at 140 mile marker and you sat there in your car for an hour, it's going to look like this, right? Just a flat line. So our velocity is 0. That slope of that horizontal line is 0. The other weird thing you're going to see on the graph happens in this last interval where the line is going down. So that doesn't mean that you're driving backwards. What it does mean is, in this kind of thing, you've probably turned around. So you went to mile marker 280 and then maybe you looked in the back seat and you left your phone or something happened, someone called and you had to turn around. So this line here, I mean, you can still measure the speed from the slope, but it will be negative, and that just means you're doubling back, heading back the way you came from. Here's a graph I put together, assuming I got in my car and I drove to Wakefield. So I'm starting at noon at my house, so my distance is 0. Now, Wakefield's in Quebec. Maybe I'm going up there to do a hike or some kind of fun outdoor activity. I live in Barrhaven, so what could be happening as I drive? Well, I live in the suburbs right now, so it takes me a little while to get out of the suburbs. So my slope in this first section is rather shallow because my speed is not very high, right? I'm covering only 7 kilometers in 15 minutes because I'm stopping at stop signs, dealing with traffic. Now, if you're going to go north from Barrhaven, you get on the highway and you drive really fast. So for 20 kilometers, I'm really booting it. My speed is what? It's going to be 27 minus 7, 20 kilometers divided by 15 minutes, which is 0.25 when you convert it to hours. And that gives me 80 kilometers per hour. So I'm always on these distance time graphs. So I want to find the speed I'm going from it. I take the distance, which is 20 high, between 7 and 27, and I divide it by the run. So rise over run. I'm talking slope here. I'm trying to avoid using those words, but that's what I'm doing. Okay? And that will work every time. Okay, so I got on the highway. Maybe part of that interval I wasn't on the highway because it's a good day if I'm only driving 80 on the highway. And then I have a terrible half-hour interval here where things don't seem to be progressing. What's happening? What could be happening? Well, maybe I'm trying to get over to Quebec via King Edward and it's crazy busy truck time and I'm just stuck in traffic, right? So I would guess that I'm stuck in traffic. Maybe I stopped, have a snack. Who knows? I get going again. I'm probably on the highway, heading up the 105 for 12 kilometers. Now I know, because I made this question, I'll put the thing on, that 12 kilometers doesn't get me to Wakefield from the start of the highway. So I must have stopped. Maybe I'm in Chelsea. Maybe I'm having a cinnamon bun in Chelsea and I'm hanging out talking to people for half an hour there. And I'm going to get back in my car and I'm going to start driving to Wakefield. Back roads maybe. Doesn't look as fast as the highway driving, does it? I hit here and suddenly the graph is going down again. I left something behind in Chelsea and I had to double back to pick it up. And then I finished my trip by getting back on a highway, probably. The first part might be me trying to get out of the traffic in Chelsea. This might be back on the highway here. And then I make it to Wakefield, 63 kilometers away from my home. What would I do if I wanted to find my average speed for the entire trip? This one's trickier, right? Because you've got a negative chunk. You were still driving though, so you have to include that. So I need to kind of break it down. I'll switch colors separately. I need to find my average speed in here, as well as here, and here. So it ends up being something that you add on. So watch out for that. I'm not going to test you on a question like that, but you have to be aware of it. How would we do it mathematically? Well, let's figure it out. So we need to think about the total distance we traveled. So from this point, to call this point A, call this B and C, it's pretty straightforward. It's 47 kilometers. So we know that our distance is going to be 47. I'm writing all over the place here. And we have to do a little math the wrong way to figure out between A and B. We're going 47 minus 42. 5 kilometers the wrong way, but it's still part of our driving. And then once we get to point B, between point B and C, we're going to have 63 minus 42 is 21 kilometers. So even though it's a 63 kilometer trip, the distance I traveled is 73 kilometers because I went to somewhere here. I went an additional 5 kilometers, realized that I forgot something, had to double back. So there and back, adding that 10 in. So be aware of that. My total time doesn't change. I might have been driving forwards and backwards, but I still took 2 hours and 45 minutes. Remember to convert 45 minutes to a decimal is 0.75. So 2 hours and 45 minutes is 2.75 hours. And then my average speed is 26.5 kilometers per hour, which sounds terrible, but makes sense. I was sitting around here. I was kind of sitting around here, like it eats up time. So there you go. Finding average speed in word problems. So make sure you read it through. So you start driving at 10:17 and you finish driving at 10:39. And you've covered 8.4. So that's what I need for the first question, which was what was my average speed on the way there. So you have to do a little bit of subtracting. So I see that if I take 39 minutes, luckily nothing rounded over, and I subtract 17 minutes, it gives me 22 minutes. I want to divide that by 60, which is going to make about 0.37 hours. All right, now I'm ready to find my speed. 8.4 kilometers divided by 0.37 hours. And that's going to give me 22.9 kilometers per hour. Who makes these questions up? Oh, I do. All right, now we're going to sit around and talk for a while, and we're going to get back on the road at 11:02. Take a different way home. Get there at 11:41. Traveled 10.5 kilometers. What was my average speed on the way back? Same thing. 41 minutes minus 2, 11:02, gives me 39 minutes traveled. I divide that by 60 to convert it to hours, which is 0.65 hours. So my speed is the longer distance divided by 0.65, and somehow I managed to even go even slower. 16.2 kilometers per hour. Really dragging my heels here. Now, this question is not asking me for the average speed during my entire trip. So if it were, I would have to include the time that I was at the dealership talking to the parts manager. So my distance would still be 8.4 plus the 10.5, but I would have to take that extra chunk of time and add it into the time. So it'd be super slow. But that was not what I asked for, so we are off the hook for that. We're just going to take the 8.4, the total distance, plus 10.5. So that's our distance, and our total time that we were driving, 0.37 plus 0.65. And this will find us a speed. That will give me 18.9 divided by 1.02 hours. Average speed of 18.5 kilometers per hour. Go. Here's our final question. It's a long one. Sounds like someone's just narrating it to me. So what am I going to do with all this information? I'm just going to pull out the stuff I need, and I'm going to put it in a table so I can see it better. So between 8:45 and 9:30, I traveled. That's not really a table, but I'm just kind of doing a list. I traveled 26 miles. And then you hung out for a while, and then between 10 o'clock, whoever did this is kind, at 1 p.m. I traveled 183 miles. And between 1:45 and 7:30, I traveled 273 miles. So here they're asking, what's my average speed for the entire day? So you kind of have like some things you have to think about, which is, are you going to include the times where you were not moving? We are, because we have been. If you're confused on a test and I haven't been clear, just ask me and I'll clarify. if you're good at counting time, you can do it all from start to finish. But if it's giving you a headache, you can totally break it up. Like 8:45 to 9:30 is 45 min. And I'm just going to change everything over as I go, which is 0.75 hours. So that's going to get added in. Here we have 30 minutes, which I can do pretty quickly, 0.5 hours. Sweet. We have 10, 11, 12, 3 hours. 1 to 145 is 0.75 hours. This last one ended up being tricky no matter how you look at it. I always do, I'm like, well, if it had been 1:30 to 7:30, it would have been 6 hours. But I started at 1:45, so I've got to do 6 hours minus that 15 minutes. I'm over, so I'm going to have 5 hours, 45 minutes, which I'm going to convert to 5.75 hours. Okay, I'm going to highlight the things that are going in because there's a lot of information to find my total time. All right, these are the numbers I'm going to add up. That total will be 10.75 hours. I'm going to add up on the other side all the distances I covered, because that's not cumulative. I did this in this 45 minutes. I did another distance in this 45. So I'm going to add up 26 plus 183 plus 273 should give me 482 miles. My speed is 482 divided by 10.75 gives me 44.8 miles per hour. So pretty respectable even with those stops. And that's all I need to talk to you about speed, distance, and time.